Welcome allemaal. I mean, welcome everyone. We're going to start, so let's fire up this thing. It's a bit old-fashioned device. Yes, it works. So, welcome everyone to the Internet of Drums talk. Let me first explain what the result of the talk is, or my project. So, it's a drum machine. It's on the desk over there. Can I point this with my laser there? And it has 3 inputs, MIDI, or I mean 2 inputs, internet and power. And it translates internet drum beats, oh wait, this is too soon, to MIDI drums. And now my favorite slide. This is going to last a few minutes. This is me. Is this range not good? 41 euros. Ah, right, it works. So this is me. I work at Luminis. I'm a senior software engineer, which is a software engineer with more workload. I am a full stack developer, so officially I am supposed to do more than just program Java. I asked my kids how they would describe me. These are 2 of the words that they used. These are my websites, and I have some hobbies. I like running outside, obviously not in the winter, and I like to play some. I'm sorry. Oh, and I'm a fan of physical comedy. Was it a joke? Well, I did this because last time I did a presentation in Amsterdam, someone was wondering if all my comedic talents were incidental or planned. So it's always planned. Oh, see, that wasn't an accident. Let me put this back. Oh, and that neither. So okay, let's start the talk. So this is me. Why the Internet of Drums? So why did I come up with this project? Let's move this before it's incidental. So I wanted to do something with programming, with skills, something educational, something that should be fun, like Sam did in his keynote. And I wanted to do something that inspires others to do something similar, or learn a new technology, or do something that they didn't do before, but they don't know how to start. So. And also, I used to be a DJ, so that's me. Wait a few seconds. Yeah, that was me. He can dance as well. So I used to make music when I was younger. It sounded like this. So this was 10, 15 years ago. I didn't have a beard then. Same body still, which is a feat by itself. And I used to make music that was put on records and then played by 10 people. And Spotify once paid me 25 cents or something for 25,000 plays. Really. Okay. So some other projects that inspired me to do something like this is this, for example, a MIDI organ. It's a musical instrument, so that it's a classical organ with pipes that air runs through, but it's driven by a computer, so you can input a musical file. You don't have to play the organ, you don't have to be able to play it, and then it plays it for you. Or this is a piano that can be played by a computer. This is done in a performance by Aphex Twin, an English artist, a Scottish artist, and he decided to put his piano on his swing. I don't know why, but it sounds very fun because you hear a Doppler effect. And he wanted to hire a piano for this, but nobody would hire a piano for swinging, so he brought his own. And another project is this. Someone hooked up the Nintendo music system to a piano and a drum kit. So watch the keys there. There. When he starts flying. So this is only analog sounds, but digital input. Cool, right?
I just talked to Jesus. He said, "What up, Jesus?" I said, "Shit, I'm chillin', trying to stack these millions. I know he the most high, but I am a close high. Mi casa su casa, that's our Costa Nostra. Ah! I am a god."
That's great. She's trying to make a billion.
I like stacking these millions. Yeah.
Stacking millions is more relatable.
So when I came up with the idea of the Internet of Drums in November last year, I thought it was a good idea, and I thought it was easily feasible to make a drum computer. And I was during this whole time, up until yesterday, I was reminded of this promo film. When Kanye West decided to put out a new album, he told producer Rick Rubin, "Hey Rick, I have a new album. Would you like to produce it?" And he said, "Fine. When's it coming out?" "Oh, in 5 weeks." "Oh, how far along are you?" "Well," and he showed him some samples there was no rap on it, and it was half finished, 30-second loops. And so later in interviews, it was a great album, by the way, that came out of it. But Rick Rubin told everyone that he was panicked the whole time. And the same goes for me, because during this project, I was panicked the whole time up until just now, because the internet didn't work, which is quite essential for an Internet of Drums device. I wish I could do this. So what was the idea? A bit more concrete. So it should be something connected, because we do stuff with the Internet of Things. It should be interactive, so you can play along later on. It should be creative, because I like the creative discipline and the technical discipline meshed together. It should be open source, so everything I've built, you can build yourself. It's all on GitHub, which I will show you later. It should be modular, because at Luminis we built modular software, and I wanted to showcase how modularity can also be modular in hardware and in every aspect of this whole project. It should be sexy, obviously, and accessible. So this is my youngest daughter, and I was trying to figure out if she could use a drum computer. So this is not the Internet of Drums, this is just a drum computer you can buy on the internet or in a store. And she figured it out pretty quickly, so I was confident that this should also be accessible enough. So, well, drums, it sparks the imagination. Everyone knows something with drums. If you're not a fan of Phil Collins, you could do African drums, or I don't know, drums. There's a lot of musical gear that you can connect with that play drums. For example, this drum computer, but there's plenty of software that plays drums as well. We have a director that plays the drums. Everyone drums, and it's fun. Drums are fun. So a bit more concrete, it should be an IoT device, so something internet goes in and something musical comes out. And you should be able to control it. Those were the boundaries of the project. And you should be able to do it yourselves. Oh, by the way, I've sprinkled this talk with lame drummer jokes to spite Laurens, because he's a drummer. So, a drum beat. What is it? First, some musical theory before we dive into the technical details. So a drum beat is a rhythmic pattern that you play. It has meter and groove, which I will explain. And you play it on either an actual drum kit, analog device, or a chair, or the plastic box over there, or a digital one, or a combination of both. So, meter first. What is meter? According to Wikipedia, it's this. And for the more visually and inclined people, this is an example of a beat. So this is a drum pattern. It has 16 notes, 12 instruments, and they are played from left to right. So all 12 instruments are played. The first note is played, then the second note, then the third, and it sounds like this. So this drum beat pattern is divided into quarters, so there's 4 beats on every count. You can subdivide it by adding hi-hats, for example. And you can add more structured sounds. You can divide it further. So every 16th note, a hi-hat, or I don't know what this is called, something, a ride is played. Thank you. And that sounds like this. So remember this, because this is what you are going to do later on. There are types of rhythms. This is a very regular Duple type. So the beat is divided into two. And every second note, something is hit that you can also divide it into triples, which sounds like this. It's a bit more exotic. It's not very poppy. It's still very regular. And you can also add feel to a rhythm. For example, a rock rhythm feels like this. So you can put any rock track on top of this, I guess. And you could add a little more swing if you hit the snare drum at the end twice. So it feels more, it's still the same 16 notes, 12 instruments, but it has a bit of swing because you hit the snare drum twice in a row at the end. Okay, so this is how you create feel for a drum type. You can also do something with samples. So you can play drums on a drum kit, which could sound like this. So this is an acoustic drum kit, something you could buy in a store and hold in your hands. And this is another drum kit with the same pattern, but it sounds a bit differently. So it's also an acoustic drum kit, but it has a different feel because it sounds more dry. But it's the same pattern that's being played here. You also have electronic drum kits. For example, this is an electronic drum machine. MIDI signals, drum signals go in, and same pattern, but electronic music, sampled drums. So this is more hip-hop-like, I guess. Same pattern, different samples, also electronic. More laid-back feel, something I play in my car with the windows open until my daughter say, "Dad." Then I play Jip and Janneke again. Okay, another thing you can do with rhythm or drums is adjust the tempo. So still we are creating a drum pattern, but with the same pattern we can create different feels because we adjust the tempo of it. So this is a slow tempo. This is the drum pattern that's being played. It's very slow, you can slow dance to this. I wanted to do this live, but couldn't find a partner. And the white dress didn't fit me. You can also play it a little faster, like this. So same drum kit, same drum pattern, different tempo. And if you play the same pattern, same drum kit, really fast, you get a sort of drum and bass feel. Okay, so this is how you can influence the feel and the sound of drums. Okay, so the architecture. So what does the project look like? And all of a sudden I'm thinking I forgot to prepare one slide, not this one. I shouldn't have said this because now you know that I didn't prepare one slide. Anyway, so the project, I was thinking, how do I create this? So the most logical thing is I should create a device, the thing that plays the drums. So that's this. This is the device. But where does it get its drum patterns? It should have some kind of surface. Maybe it's an IoT thing, so something on the internet that it gets its drum patterns from. And then the next logical step is how do you get these drum patterns into that surface? Nog een keer. €41. Logitech. So a client with which you can create drum patterns, which you just saw. You can create a drum pattern and upload it. Then the client gets the drum pattern, and the machine can get it from the service again and can play it. But what is a drum pattern then? You have to have some kind of definition that the client and the service and the drum computer adhere to. So you have to define what a drum pattern is in this case, because otherwise it maybe doesn't work. You have to write a specification for that. So what is a drum pattern? What does it consist of? And just for fun, because I should have been doing more important stuff, I wrote a validator. So if you think it's not working, at least you can validate that your drum pattern is correct. And when all is done, you can deploy it to a web server. So the client and the service, they have some sort of configuration that you can deploy, and then it works. And some artwork, very important. Oh yeah, this is a slide, by the way, that I forgot. But you can, in your mind's eye, you can see this now, right? So you have the drum machine, it's connected to the internet. Somewhere in Amsterdam, a cloud server is spinning. It has a service and has a client, a web client. You can, from your telephone, can connect to this internet server. Then you can use it. So that's a classical IoT architecture. The most important thing first, so I create some artwork. I've also created some stickers. So if the demo fails, I can fix it with stickers and a banner for Twitter. If you go to the Internet of Drums GitHub webpage, you can find the artwork here. So if you want to copy my project, be my guest. It even has a license, which states you can copy this project. You don't even have to say you stole it from me. It has a README, which is important, because then you can recreate the project and you know how to. There's not a lot of info in this, because it's artwork, right? You just do something. It's art. Okay, so I learned something from this. So every project I learned something. I learned that I really love the Adobe graphical suite, but it's really expensive. I used to work at a company where they had cheap licenses. Now I have to pay it myself. So I tried open source stuff, like name something, Inkscape. It's okay. And I miss doing the graphical stuff. I love doing this project because I also could do something that I don't do in my day-to-day job. Okay, so then the specification. So how do you describe an internet drum pattern? So I started out with 16 instruments, which didn't fit onto the hardware, which I'll explain later. So 12 instruments in 4/4 time, so classical pop time rhythm, which you just saw. Each instrument has 60 notes, which are played consecutively. Each note should have note length, so how long are you playing the note, which didn't fit into the project, so it's now not in the specification, but still on the slide. And velocity, so how hard do you hit a drum, for example, a snare drum. You can encode this, then you get a string of bytes, for example, and then you need to encode this, because otherwise, maybe during the internet travel, it gets blocked because it's binary data and not all access points or hops like binary data, so you have to encode this. So if you go to the GitHub webpage, you can see the specification. It's just text, but it's very clear what it is and what it is not. So if you want to recreate a pattern, you can read exactly what you should do and how it is encoded, which was quite hard. So it looks like this over the wire. So if you have a pattern, you start at instrument 1, note 1, how the velocity of the instrument, so how hard you hit it, then note 2, note 3, note 4, until you get to instrument 2, note 1, until the last instrument, the last note. So it all gets sent at once. So what did I learn from this? It's really hard to write a specification. I much prefer just coding and then later on doing documentation, or not doing documentation as I usually do. I think spec writing is a real discipline. I have a lot of respect for example, all these RFC writers. It's a hard job, and the most scary thing is once you're done, that's it. It's set in stone. So if you later on decide, well, this was not what I was thinking, then you're too late. Not in my case, but if you write an RFC or something. So respect, or respect, as we say in Arnhem. Okay, so then a validator. It was January, by now February. The project wasn't going too fast, so I thought, let's learn a new language. So I wrote a validator, which validates internet drum patterns. So here's the open source GitHub project page again. So it's written in Go, which is a nice language. You install the validator, and then you feed it one argument, the pattern, and then it says this is a pattern that's correct or it's not. So if you put in a correct pattern, a encoded pattern like this, it says, yes, this is an internet drum pattern. And after decoding, it looks like this. So this is instrument 1, note 2, note 3, note 4. So this sounds like drum beat, and then, yeah, it sounds like nothing rhythmic. And if you put in a wrong internet drum pattern, it says, no, it's not right, and it says why. So what did I learn from this? So the Go language is relatively easy to learn. It's a very well-documented language. It's very opinionated, so it's easy to program in, because if you make a mistake, you get immediate feedback, and there's not a lot to screw up, like in Java or something. And it's fun. It's fun to program in. Okay, then the actual definition of a service. So the endpoint, the service, is a RESTful web service where you can upload drum patterns, and you can get a queue of drum patterns, and you can get the head of the queue of the drum pattern. And to write or to define the service, I used the OpenAPI specification. It used to be called Swagger, but now it's called OpenAPI. And you write your specification in YAML. I stole this idea from my colleague Peter, which has turned out well. So this is the specification. The repository has one file, this one, which contains the specification of the web service. This is really slow. If you're standing up here, this takes... Oh, there's nothing in there. Oh yeah, right, you can click this link, and then you go to this page. No, not this page. This is specification. So it states this is an OpenAPI specification. It's called Service API. This is the URL, and one operation is endpoint health, which you can get, HTTP get. And if everything works, you get a 200 OK header, and that's it. And if it doesn't work, then you get an error. So if you want to test if your service is online, this is the way to do it. And the great thing about this is that you can feed this into some kind of document generator. So you just create a YAML file, and then you feed it into a generator, which I didn't write, a document generator, and it generates documentation for you, which is great because the only thing you need to change now is the specification file. So I don't really like writing a lot of documentation, especially after the fact, and this is a way to not having to do this. You only have to write the specification. You can also generate code. So if you take the specification and you like, you would like to have a Node.js web service, I can't imagine why, but you can do this, and then it generates the code for you. And if you spin this up, you have an implementation of the web service, a correct one. So what did I learn from this? I like this approach because you are forced to think about the user, the machines or the humans that are going to use your specification. So you are forced to be very clear about what you do and do not expect people or machines to do with your specification. So before you dive headfirst into creating a web service, you are forced to think about what you are going to achieve, which may be natural for software architects, but not for me. And there's a lot of tooling available, so it's very, very easy to get feedback on what you're doing. It's not very hard to learn. Okay, and then you have to write a web client, which reads and writes the patterns into the service. So I thought, well, it's 2 weeks before the DevCon. I have time. I'm going to learn a new technology, Vue. I heard a lot about Vue. I thought this is a good time to learn something new. Webpack as well. I learned grunt and gulp and all that, but I thought we have time. Let's learn something new again. So the deployment is done in Docker, and the project looks like this. So there are a lot of instructions on how to build this project. See, 2 lines, and how to run it. And there are no tests, but if there are, you can run them. I did have time to learn something new, but not to write tests. Okay, so this is what the client looks like. So later on, you're going to use this client. So as you can see here, you can create a drum pattern. There are instruments here. So this is the bass drum, for example. And this is the snare drum. And this is the hi-hat. And you can click and create a drum pattern. And you can hear it over the audio system later. And you should give it a name. And if you're done, you can click submit, and then it goes into the queue. So what did I learn from this? I liked the Vue technology, but it was hard to learn for me because I really liked the approach where you define HTML in an HTML file, and styling in a CSS file, and markup in an HTML, or code in a logic in a JavaScript file. But once you get used to the workflow and the model, it's fun. It's fun to do. I don't like the Webpack's magic, because you're with gulp and grunt, you can program your build, but with Webpack you just configure it. I like Maven, which is the same, so that's maybe a bit contradictionary, but and I use CSS Grid for this, another new technology I've never used, and animations. Okay, so then the implementation of the actual service. So nothing is working by now. Half of it was broken 1 week to go. No, this is not true. 1 month ago, and I decided to learn a new technology because I thought I can do this. It's easy. It's Java, but you can. I used to program Java 7, 8. You can also program in Java 9, modular Java, which is fun. It has a bit of a learning curve, but I had time. And but Maven has tooling. How hard can it be? I also thought, wow, I should learn more new technologies, so I decided to learn Vertex. Docker I already knew, so that was, well, maybe that saved the project. So this is the project. You can check it out on GitHub. It's a standard Java modular app, which you can build with Maven. You can check it out and then run it locally. And it looks, the architecture of it, or at least the modular part of it, looks like this. So you have this is a definition of the service itself, the objects that are in it, and the interfaces that you will use. And the actual implementation of the web service, the actual web part, doesn't depend on the API, which is great. It's actual modular code. You have to write an implementation of it, and then you depend on the implementation. And to the web stuff, I used Vertex Core and Web, and Jackson to create JSON stuff, which went okay, but they are not modular yet. So I hoped that I would end up with a purely modular application with a very lightweight runtime, but I didn't because I'm such an early adopter. So what do requests to this web service look like? You can post a pattern with a name and the pattern itself. You don't have to do this by hand. Your client creates it. If you want to, you can. And then, whoa, 41 years. Then you get a response. It says, if everything went okay, it says, I created I added it to the queue, and no content. So you can get the queue back. You do a request to the patterns endpoint, and then you get a response. So this is, for example, a queue with Billie Jean and Voodoo Ray, all these classics on it. And if you want to have you cannot see the pattern here. You only see its name and its ID. And if you want to get the head of the queue, it's a classical queue, then you do a request to the queue, the head of the queue, and then you get the pattern back. So this computer needs to request the head of the queue, and then it gets a pattern, which it can translate to a MIDI signal. A what signal? I will explain it later, and then it will play it. So what did I learn? I really like this new Java modularity thing. Maybe you should consider it in .NET. Modularity is awesome. It's not easy to be such an early adopter because stuff needs to be figured out. For example, the Gradle builds don't work easily. Maven does. Okay, so now the most scary part to me, hardware stuff. I'm a software developer. So the device. So the definition was internet in, MIDI or music out. So I very quickly decided to use MIDI to signal music. So this is a MIDI cable. MIDI goes into a drum computer. MIDI goes out from the Internet of Drums device. This thing here contains an Arduino, which you can't see in the back, but it has an Arduino, lots of wires as well. And you have to write in C, but if you know Java, JavaScript, C is not very hard to learn. Memory management is easy. Pointers. I made 0 mistakes with pointers, by the way. Okay, so that was not a joke. And laser cutting I used to build the case, because I know how to design stuff. And in my mind, like Neo in the Matrix, I can envision a case and do a 2D projection. So no mistakes there either. I did have to use a lot of wood glue. So you can also check out the code for the Arduino software for the actual heart of the drum machine. You can download the Arduino IDE, hook up an Arduino with an Ethernet, what do you call this thing that you put on top of an Arduino? Shield, thank you. And then upload it and it should work. It looks like this. There's a link to the simulation of the Arduino, so you can check out what the code does. So you program in here online, and then you can see if your logic would work in real life. So the lights logic, I programmed this online. These are shift registers, and it even shows you when you're breaking stuff, which is very cool. And you can check this out as well online. So what is MIDI? What does this cable do, if you don't know yet? So MIDI is a very old protocol to signal musical stuff to instruments. So it's a real-time protocol. So you send messages to an instrument, and it plays music for you. So a MIDI has events. And for example, if you want to play a bass drum, you send a MIDI event. So a note on event and a note, for example, C0, the 15th key on your keyboard, and then the velocity. So how hard do you hit the key? So a bass drum hit, you send a note on signal on channel 10. All drum computers listen to channel 10, and note B0 is the bass drum that's defined in the specification. And you can hit it as loud as you can if you send velocity, max velocity, which is half 127. So this is a MIDI cable, and the bass drum signal is coming in. See, it works. So you send as fast as you can, you send these signals consecutively, and when it has deciphered an event, so 3 bytes in this case, it plays the bass drum. Nog een keer. Whoa. Okay. MIDI, hooking up MIDI was fairly easy. You hook up the MIDI port, which is here. And you hook up ground and voltage, and then you use a serial port to send signals. So it's just using serial communication. You already seen this. So then the case design, I used very high-tech methods to design it, and then you send it off to laser-based in this instance, and they cut it out of plastic for you and wood, which is very cool. And then they send a movie if you ask them for it. And they even can engrave logos. So here's the Internet of Drums logo engraved with a laser. Very cool. Looks like a matrix printer. And then you get it back in the mail, and you can unpack it screw in the Arduino, some drive fitting. You attach a MIDI port. Then everything fits. You do some wood gluing, some clamping. Not to be confused. It was supposed to be a good joke, but the 41 euros. It's not to be confused with clamping. So, and then you're done, and you can admire your work, which is very important. Then you can put in the LEDs, LEDs, and then do some soldering. Not to be confused, now it works. Not to be confused with soldering. It's a Dutch joke. And then you're done. So now you're done with your hardware. And then you can test it. My daughter helped testing. It's a freestyling. And I learned something from this as well. It's very fun to do Arduino stuff because there's lots of documentation. And everyone is friendly, unless you're not friendly online. You can get a lot of help. If things break, it's probably easy to find a solution. If not, you can ask on the forum, and people will help you. It's just one guy, I think, because I saw his name everywhere. And it's, no, really, some Italian guy, nice guy. And it's relatively cheap. It doesn't, oh, wait, I just remembered I forgot another slide, because how cheap is it then? I said to my wife, wow, I have 4 hours before my presentation starts. I will do this later. She said, you should do it now. You're going to forget this. I said, no. So it's relatively cheap. Couldn't be more than a few. I think maybe I spent more than I should have. I have a lot of extra stuff for new projects, but it costs 40 euros or something for everything, maybe less. If you get it from AliExpress, it's less. Okay, so now, now is the most important part, the actual demonstration that it works. I didn't know Aaron would be playing the keynote. Otherwise, I wouldn't have done this project at all. But this is less impressive, but still. So, can someone be a volunteer? Do we have internet connection? Oh, I have to reset my internet connection. You can check your Twitter. You can go to the internetofdrums.com on your mobile in the meantime. Pate, Wi-Fi. Oh, right, so now I have to, do I have to do something? internetofdrums.com. Welcome. Connect to Wi-Fi. Yes, non-secure form. Yeah. Then I have to share my internet connection. The queue. Does it work? Yeah. Okay, so this is the queue. This is the client. And I can hook up the internet drum machine. Oh, I have to share my internet first. Sharing. Yes, it's shared. So, okay. I can create a drum pattern for this. I'll do it myself. I don't need you guys to do it for me. Really? Oh, this is the queue. Everything's queued up already. Okay, so now I connect the Internet of Drums device to the internet. And then it should play this queue. So it should start with Philip. Let's see what Philip has created. So now it's on. I have to send out a MIDI signal. Oh, it's already playing, but you don't hear anything. Okay. All right, so this is you. So the internet machine, the drum machine, is connected to my computer with a MIDI cable. And now it's playing these patterns. So this is you. Who is this? Oh. This is an empty pattern, probably. Next. So this computer. The Arduino is connected to the internet. It downloads the drum patterns and it sends out a MIDI signal to my computer. And I have a GarageBand running here. And GarageBand, I added an instrument which listens to this MIDI signal. So the sound is coming from my computer now. It's a virtual instrument. But I could also hook it up to my analog drum machine. I would play that, or I can change the sound here. I am sorry for this is coming up. I'm excited for this. Sounds fairly okay. So this client, part of the client is this view of the cue. This is the cue, and here you can see which drum pattern is playing now or has just played. Well, you're quite talented, I must say. You have listened to some well. Let's change up the drum kit. Yes, that's better. Who did this? Give your instruments names, please. Wow, this is someone that is familiar with these kind of patterns made this, I guess. Bit busy. This is mine. This is a good load test, so it still works. So this is deployed on a Digital Ocean droplet, the cheapest one they had. All right, it's a joke. So what did I learn from this whole project? In the meantime, you can still drum. So I was really convinced I was a pragmatic programmer. Some people said to me I wasn't. Peter said to me I wasn't, for example, our architect. But I didn't believe him until I did this. So I didn't know when this new information came to me, but it was around the time I was crying that it didn't work and I had 2 hours to finish the project. But now I've learned this of myself. So you have to be a pragmatist, you have to choose between something that works, something that's correct, or something that's done fast. So I always pick correct and the other one, but not fast. It's very hard to design something simple because this is a relatively simple project, but it still takes a lot of time because you have to define everything correctly and then program it correctly. Otherwise, it wouldn't work, this kind of architecture. Yeah, Murphy. So everything that could go wrong did go wrong. For example, the drum definition with 16 instruments that had velocity and note length, it doesn't fit into an Arduino. And I was already done with the project when I discovered this. So I hooked it up. I plugged in the internet cable, and it showed me a warning from you have 4% memory left. And I thought that's 4%. I have something left. But something with memory management in C, it's not hard, but. So I had to change the definition of an internet drum pattern for this, and then I had to change the client, the service, everything. I short-circuited my wires one time. It took me half an hour to and some screaming. Sorry, Moron. Anyway, well, I discovered that it's great to do something within your comfort zone. So during the day at my job, I was much happier because I could do something that I already understood. But it's still fun to do such a project, I think, especially when it works. So you can join this fun. See, I'm having a lot of fun. by going to the GitHub page or following the project on Twitter. I will make some other stuff. And you can get some stickers if you want to put on your laptop. I already did this. Looks very cool. So that was it. Do you have any questions for me? Oh, I have a microphone for questions. I will repeat the questions. Oh, thanks. It wasn't a question. Anyone?
The other, you only connected 3 of the 5 MIDI.
Right. Mm-hmm.
What do the other 2 you haven't connected to? What should they do? What could they add to your product?
So this one. I have no idea, really. I don't know. Well, I think this is a generic DIN connector. Oh, right. See, people are nodding. So I only connected these wires because that's all you need for a MIDI signal. But if you have a more complicated project with a DIN connector, you can use the other ones. I don't know what they're for. I don't know what 90% of the whole project is for, because I had to go fast and break stuff. I'm a pragmatic programmer. That's what I do. It's not that funny. Okay, so any other questions? No? Okay, then you can have a proper break now, because we are starting at half again. Or no, everything is delayed by 10 minutes. So at 5 before half. What's that in English? 25 after. Okay, so have fun today. And thanks.